Hi all. In this video, we are going to see a paper titled Neural Discrete Representation Learning. So this paper put an effort to introduce a novel generative model combining variation autoencoder with the discrete letter representations framework using vector quantizations. So making instead of continuous letter representations from the encoder network, it tries to output discrete letter representations using vector quantizations. For the reason that uh, the normal variation autoencoder, which outputs continuous letter representations, has a huge variance during the training time, and it's very hard to do a proper output during the generation times, and this is normally called as posterior collapse. So in order to avoid posterior collapse, it combines with vector quantization letter representations with variation autoencoder. So this variation autoencoder is similar to the traditional variation autoencoder. The encoder framework is a parameterized network, and it outputs a Fourier distribution for the letter representations conditioned on the input data given a prior distributions. And the decoder with the given prior distribution with the input from the letter representations, it outputs distributions of the over the input data. So this setup is nicely described in this paragraph and beautifully represented in the this figure one. So we are going to see this figure one and what that paragraph is describing about. So given that input data, we have an encoder network based on CNN, and it's going to give a latent representations. So once it gives a lot of representations in a continuous framework, it will try. It also has an embedded space which has k vectors of dimension d. So this output is going to find the nearest neighbors among these vectors, which is very nearest. That vector is being retrieved, and that retrieved vector is given back to the decoder framework in order to output the reconstructed image. So this is what the overall all about this VQ-VAE, and based on this is being trained based on these equations three. The first term is related to the reconstruction error, the decoder framework, and the second one give much priority to how the embedding things like how the retrieval from that embedding space and how the output of the latent space has to be given more high priority using that vector quantizations, and that loss is been embedded in the term 2 and 3. Especially the term 2 is what been described as an L2 error to move the embedding vectors towards the encoding output. So these are some of the novelties being introduced in this paper, like letter representations using vector quantizations in a variation autoencoder framework in order to avoid the posterior collapse. Hopefully, we will see about the updated version of this VQ-VAE in some other paper in the next video. Thank you.